So now we're going to demonstrate the organic intelligence AND gate. Now the AND gate has two inputs and one output. It has a resonance frequency for 147 megahertz, and it's made with 7 organic intelligence base units. So this is the board I'm using right here. It actually has several circuits on it, but the second one is the AND gate. So I'm going to connect the inputs and the outputs. All right, so I'm going to connect input A to the output of the function generator, the output number 1 of the function generator, and input B to output number 2 of the function generator. Okay. And I'm going to set the frequency to 147 megahertz for output number 1, and also for output number 2, 147 megahertz. The amplitude I will set to 1 volt, peak to peak, and for both channels. Great. And no offset and 0 degrees phase shift. All right, and on this, the output of the AND gate will be connected to channel 1 of my oscilloscope. All right. All right. Okay. Let's make sure everything is good. All right, so as you can see, both channel 1 and channel 2 are off right now, and they're not turned on. And as you can see, channel 1 is set to 147 megahertz. Channel 2 is also set to 147 megahertz. 1 volt peak to peak on both, 0 degrees phase shift and 0 volts offset. Well, as with any AND gates, if you have two inputs that are 0, then the third or the output should also be 0, which is the case. So we know that basically works, which is basically case number 1. And that's obvious. So now let's turn on channel 1 on the function generator, which will basically be, actually, let's turn on channel 2, which will be case number 2. Basically, it's input A will be 0 volts or 0, and the input B would be 147 megahertz. So let's turn on input B, which is set to channel 2. And now, as you can see, on the output of the scope, we get a signal that's 104, fluctuating between 104 to 112 millivolts, and the frequency is 147.25 megahertz. All right, so that basically covers case number 2 of the AND gate. So now for case number 3, it basically states that input A should be 147 megahertz and input B should be 0. So let's turn off input B. So input B is now 0, and let's turn on input A. Now input A is now turned on to satisfy case number 3, and we also see we get on the output basically 104 to fluctuating between 104 and 112 millivolts, and the frequency is 147.25 megahertz approximately. So as you can see, we got exactly the same results as case number 2, which is expected. Now, for the last case, which is case number 4, according to the truth table, we should have channel 1 on the function generator, or input A, should be 147 megahertz, and input B should also be 147 megahertz. So let's turn on, well, channel 1 is already on, so let's turn on channel 2. So now, because these are two independent channels, I have to phase align them. So I press the phase shift. Now when they're both in the same phase, as you can see now on the output of the scope, we're getting an output of 936 millivolts peak to peak at 147.06 megahertz, which is basically what we should get on an AND gate. When two inputs are present, you should get a third output, which should be the two inputs. And that's exactly what we have here. Now, as you can see, both inputs are 1 volt peak to peak, and the output is also 1 volt peak to peak, so the sine waves don't add, or the amplitude of the sine waves is not adding. And so I can expand it a little bit on the scope, and you can see the sine wave, very beautiful there. It's 936 millivolts peak to peak as the output, with again still 147.06 megahertz. So as you can see, all four cases of the sine waves matches the truth table. And if you look at the conventional truth table of the AND gate, which uses DC current instead of AC, you basically will get a 0, 0, 0, and a logic 1, which represents a DC voltage. But with organic intelligence, the output is the same. You have a 0 for case 1, 0 for case 2, 0 for case 3, and 147 megahertz at 936 millivolts peak to peak. So that's basically an AND gate. Now, with the organic intelligence, the voltage amplitude is variable. It doesn't have to be 1 volt peak to peak. I can lower the voltage down, the amplitude, to 500 millivolts peak to peak. So I'm going to do that now on channel 2, 500 millivolts, and then on channel 1, I'm going to also adjust that to 500 millivolts peak to peak. And as you can see, at 500 millivolts peak to peak, the output is still is actually 472 millivolts approximately, which matches what the input amplitude is. And if we was to turn off, well, let's start the test over again, and let's see what happens. So here's a case now with both inputs are turned off, and we have, of course, we'll have an output of 0 because there's nothing coming in. So that's case number 1 of the AND gate. So case number 2 says we'll turn on input B and give it 500 millivolts at 147 megahertz. And you can see now the amplitude of the output is 64 millivolts peak to 64 millivolts, but it's fluctuating between 64 and 8 millivolts, but let's call it 64, you know. So that actually is a 0. So now let's turn off channel 2 and turn on channel 1. And as you can see, we also get 64 millivolts again, which is a 0. So that satisfies cases number 1, 2, and 3. And now I'm going to turn on both channels, both outputs from the function generator, which is basically input A and input B. And then I'll press the phase shift to phase align both signals. And now we see what the output is of the AND gate. It's 472 millivolts, which is, again, matching what the amplitude of the signal is. The input amplitude of the signal is 500 millivolts peak to peak. And on the output 1, or logic high, which you would say, we are also getting 472 millivolts peak to peak. Let's take it down another notch. Let's go down to 250 millivolts. Okay, 250 millivolts for channel 2, 250 millivolts for channel 3. Okay, 250 millivolts. Okay, so now I have both inputs. They're still at 147 megahertz, but the amplitude of the signal going in is 250 millivolts. So let's start over. Let's start the test over again. So obviously, if you have nothing coming in, you're going to have nothing going out. So that's case 0, or case number 1, so which is fine. So now we'll turn on and channel 2, which is input B, which satisfies case number 2. Now what we see actually, let me adjust my voltage per division now. I'll adjust it to 50 millivolts peak to peak. So now at the scope now is adjusted to 50 millivolts peak to peak in terms of the voltage per division. That's the setting. And the output of channels A and B of the function generator, the maximum now is set to 250 millivolts. So input 2 or of the AND gate, which is input B, you could say that, is now on, and you can see on the scope the output now is 28 millivolts, so which is basically a 0. If I turn on output number 1, as you can see again, the output from the AND gate is 28 millivolts, which is a 0. And if I turn on both outputs, and then I do a phase shift, a phase alignment, and now I see that the output logic 1 is 236 millivolts at 147.06 megahertz. So as you can see, it doesn't matter what the levels of the signals are. It will go down even if we had a voltage levels in the microvolts. We will still maintain a separation between what we would call a logic 0 and a logic 1. Okay, so that is the AND gate and the demonstration of the AND gate. So now I'm going to explain what's actually happening. Why is it working? Right? Now, as you notice, we don't have any power connected to the board. It's just basically the geometry, what we call the organic intelligence geometry. And we have the 2 input signals coming from the function generator, and then we have the output that's going into the oscilloscope, which you can see the output of the logic of the AND gate. So why is it working? Where is the logic being done? Where is the intelligence? Okay, so a thought field, I created a thought field which is located in what I call the spiritual dimension. Scientists call that the quantum field. In my culture, where I'm from, we call that the spiritual dimension. And I've created a geometry that matches my thought field. So when the signal goes in from the function generator, it actually activates the geometry such that it resonates now with the thought field that's in the spiritual dimension. Now keep in mind, in the spiritual dimension, the thought field that represents this AND gate is vibrating. It's already there. It's there, but it has no connection into the physical world. When I put a signal into the geometry, that causes the geometry to resonate. And by definition, anything that resonates at the same frequency must be connected, even if they're in another dimension or millions of miles away. So this particular geometry is in the same shape of the energy or the thought wave or the energy field or the spirit that is located in the spiritual dimension. So when the energy goes in of the same resonance, which is 147 megahertz, that's what I designed it for, it actually connects with the thought field that's located in the spiritual dimension. So the energy that goes in from the physical dimension reaches into the spiritual dimension, and the actual quote-unquote processing is being done in the spiritual dimension, and then we see the output here in the physical dimension. So you can think about it as the geometry is a bridge that allows us to send data from the physical world, or send energy from the physical world into the spiritual world, and have the information processed in the spiritual world and bring the data back. So it's a bridge. It's like a middleman in between. And that's basically how it works. Now, the reason why I said process is because there's no such thing as processing data in the spiritual world. Nothing is processed because everything is instant. In the spiritual world, everything already exists. So there's no processing to be done because everything happens at 0 time, because there's no such thing as time. Time is only an illusion of this physical world, so our mind can perceive what we call physicality, and we experience time and various things like that.